This begins the video for test section 40A410, which is the crack seal section for SPS4 on State Highway 3W. This is the bypass for Ada, Oklahoma, and this is on the same project as GPS test section 404160 in GPS 3. Okay, we are on the other side of the hill for it. I'll pull up and show a little panorama around here just to give a feel for the area. And back behind us is Kerr Lab Road, which is the same thing as Mississippi Avenue, which is the main drag into Ada. And there's your landmark telling you that where it is. And you can see the ramp on down probably about 400 feet back behind us, where the traffic from Kerr Lab Road using the ramp would tie into 3W here. Going around, we're in a probably about a 4-foot cut, if that's what you can judge it to be based upon the elevation of the frontage road here. And I'm standing at the beginning of the first test section. Now what we're going to do out here is we're going to have two sharp test sections. We're going to use the GPS as the SPS4 control. We may have some supplemental sites, but with the recent flooding we've had around here, the maintenance folks aren't available to meet with, and want to talk with them about it because they'll be applying those treatments and want to see whether the cost is not prohibitive to do some of the things that we've been talking about. I'll move along with the video and just kind of take this rather quickly. We don't have the only distress noted in the test section itself is some minor faulting. It's all less than 4/10 of an inch. Generally in both of the sections, typical fault reading would be around 2/10 of an inch, and we measure the faulting at every joint. I recorded that also on the way. Another thing that we recorded at periodic locations was the difference between the lane shoulder drop-off there at mid-slab and also here at the upstream facing of the joint. And something I was noticing about it was that there seemed to be a correlation between that and faulting, and what will be even more interesting is to record this for each joint where we do undersealing up on the subsequent test section, and to see where we fall there, to see whether there's a correlation between the difference or the change in lane shoulder drop off and the amount of grout that the section will take. Okay, one other thing that we see throughout here, and this is around station 0 plus 96, is a few pop-outs here and there. This is by far the most severe one, and it's about 3 inches wide and about 1.5 inches across. As you can see, we've got a slight upgrade and we're coming into a curve here. The surface drainage conditions here are quite similar to what we saw on the GPS test section, which is why we picked these out here. On that section we had about a 0.7% grade. We were in the tangent section though. Now in here we've got on that one we had 0.8. On here we've got 0.7, and we're going into a vertical curve, and we're changing grade, going up to a 3% grade in the second test section here in A420. But on that we've got a right curve which has got a super elevation of 4%. That compensates for the percent grade and allows the surface drainage to be going in the similar manner to what we see on these tangent sections. So we picked these out because they were close to the GPS section, because the condition was the same as the GPS section in terms of pavement distress, and also because the surface drainage was about the same. We're about in the middle of this test section. There's nothing remarkable about any points within here. We're fortunate also to have about uniform conditions in terms of cut and fills. We were not able to avoid culverts, and that's life. Okay, here's a point where we've got some lane shoulder drop off up above just on the upstream slab of the joint, or upstream edge of the joint, of over 1 inch. and yet down here we have around 3,500 or so, or 210, or maybe even less than that, of a lane shoulder drop off at mid-slab. And you can see how this depression increases. It's just it's a depression, and it goes from around about 3 feet, commences around 3 feet upstream of the joint, and then ends off around 2 feet downstream. I think we need to be recording that as part of the distress survey, but there is no way to do that right now. I've recommended to do that to TRDF, but we haven't had a response from them. Something that I need to do today and tomorrow is to try to get some dates down for when we plan on doing this. It's kind of a nifty thing right now with the present status of SPS4. Let me shut up and just kind of do my job out here. This ends the video for test section 40A410.